This is Trapezoids and Kites, practice 6-6. We're only doing in this video the first page, which is trapezoids. So we did the trapezoids on Friday, December 14th. And we're going to do the kites portion, the second half, on Monday, which would be December 17th. So trapezoids are quadrilaterals that have exactly one pair of parallel sides. Okay. So we've talked about parallelograms. Parallelograms are quadrilaterals that have two pairs of parallel sides. So we start at the top with quadrilaterals. Okay. The four-sided figures, quadrilateral. So lateral means sides, quad means four sides. From there, we can say there's many different types of quadrilaterals, but the 7 special quadrilaterals we're focusing on, we could split them up into 3 different categories. The ones that have 2 pairs of parallel sides, that's parallelograms. And under parallelograms, then we have rectangles and rhombuses and squares. Those are all parallelograms. They all have 2 pairs of parallel sides that are congruent. Trapezoids are the category that have only one pair, exactly one pair of parallel sides. So we're going to classify the sides of a trapezoid as bases or legs. If the side is one of the 2 parallel sides, one of the pair of parallel sides, it's going to be a base. So again, the arrow indicates which one's parallel. So we have a base and a base. And then the other 2 sides are going to be our legs. So it doesn't matter how the trapezoid is configured. Some people think the bottom is the base and the top are the base. But in the second example here it's the parallel sides. Okay, the parallel sides are the bases. The other 2 sides are called the legs. If we start at number 4, so we'll start down at number 4 to go over an example of a trapezoid. We'll do 4, 5, 6, and then go back up to 1, 2, and 3. So for 4, 5, 6, these are just regular trapezoids. It's not written in, but it's implied here that SP is parallel to RQ, VT is parallel to VS, and AD is parallel to BC. So on number 4, we have a trapezoid. Okay. So these are the base. This is the base. This is the other base. These are the legs. These are the legs. If we look at our reference sheet and we look at the properties of a trapezoid, besides having the 2 parallel sides, the 1 pair of parallel sides, the 2 sides are parallel, right? But it's 1 pair of parallel sides. We know that between the base sides, the consecutive angles are going to be supplementary. Okay, consecutive angles are going to be supplementary. So if we think back to a parallelogram, where we had 2 pairs of parallel sides, we knew that these 2 angles, so if I label them A, B, C, and D, we knew that A and B were supplementary. Okay. We have same side interior angles, and since these lines are parallel, we know by the same side interior angle theorem that same side interior angles are congruent. We know that B and C are going to be supplementary because they're same side interior angles, and AB and CD are parallel. So since we have parallel lines, the same side interior angles are going to be supplementary. Same for DC. D and C are going to be supplementary because these 2 lines are parallel. And then A and D are going to be supplementary because A, B, and DC are parallel. So the trapezoid consecutive angles were always going to be supplementary. We contrast that to the trapezoid where we only have 1 pair of parallel sides. It makes sense that we're not going to have 4 different combinations of consecutive angles. Okay, I think I might have been saying sides. If I said sides, I mean angles, consecutive angles. So this one, our only 2 parallel sides are SP and RQ. Okay, so we know that S and R are going to be supplementary. We also know that P and Q are going to be supplementary, but there's no interaction here between R and Q and S and P. They're consecutive angles, but we can't say that they're supplementary because, in fact, they're not going to be supplementary because these two lines, PQ and SR, are not parallel. And since the lines aren't parallel, the same side interior angles are not going to be supplementary. So with the trapezoid, we have one pair of parallel sides. So consecutive angles are only going to be supplementary between the two base sides. So we know S and R are going to be supplementary, so they're going to add up to 180. So the measure of angle S plus the measure of angle R is going to equal 180. We know the measure of angle S is 65. So if we do 180 minus 65, we're going to get the measure of angle R to be 115. And the question we asked in class is, can we find the measure of angle P or the measure of angle Q? And the conclusion we came to was no, we cannot. There's no relationship between R and Q and R and P, or between S and P and S and Q. Okay, there's no way we can determine with the information given what P and Q are. So that's all we're going to do. That's the only property we have for regular trapezoids, okay, which makes these problems particularly simple. You just need to recognize what it is and what property it is. So again, we're assuming here it's not drawn in, but it should be. UT is parallel to VS. So here's our parallel line. So we know these angles are going to be same side interior angles. And if the lines are parallel, right, the transversal TS is going through the two parallel lines, and same side interior angles are supplementary. So we know that angle S and angle T are supplementary. So 180 minus 92 is going to be 88. So we know that the measure of angle S is 88 degrees. And there's no way we can find U or V. Okay. All right. Number 6. Okay, number 6. Again, AD is parallel to BC. That should be drawn in. So we know angle A and angle B are going to be supplementary because they're consecutive angles that are between the bases. Consecutive angles between the bases are supplementary, which means they add up to 180. So the measure of angle A is 11x plus 8. The measure of angle B is 95. So if we add them together, they're going to be 180. Combine like terms, 11x plus 103 equals 180. Subtract 103. We get 11x equals 77. Divide by 11. We get x equals 7. 7 times 11, 77. So if we plug it in, so we have 11x plus 8. So 11 times 7 plus 8, that's 77 plus 8 is 85. We know 85 plus 95 is 180, so we know we have the right answer. Okay, so let's go back to 1, 2, and 3. So now that we have our regular trapezoids, which are defined as quadrilaterals that have exactly one pair of parallel sides, and the only other property they exhibit is that the consecutive angles between the bases are supplementary. So if we go back to 1, 2, and 3, we now have an isosceles trapezoid. Okay, so again we have base, but then and leg, but in this case our legs are congruent. So an isosceles trapezoid is going to be a trapezoid with congruent legs. So we're going to define an isosceles trapezoid as a trapezoid with congruent legs. So since an isosceles trapezoid is a trapezoid, it has exactly one pair of parallel sides. So the property for a trapezoid is still going to apply to a isosceles trapezoid, and that is that consecutive angles between the bases are supplementary. So just like in the Latin 4, 5, and 6, 58 plus the measure of angle 3 is going to equal 180. subtract 58. 180 minus 53 is going to give us, or 180 minus 58 is going to give us 122. But we can use some properties of isosceles triangles to find angle 1 and 2 now. So in 4, if you go to 4, right, we couldn't find P and Q. P and Q were not related to S or R, so we didn't have enough information to find them. But if it was isosceles, like number 1 is, we can find the measure of angle 1 and the measure of angle 2. And those properties are that the base angles are going to be congruent. So base angles are congruent. So if it's 58, 1 is going to be congruent, so it's also going to be 58. And then 2 and 3 are going to be congruent. So if this one's 122, 2 is also going to be 122. And again, these should be consecutive angles that are supplementary, and they are. 122 plus 58 is 180, just like on the other side. Okay, so base angles are going to be congruent. We also notice that 1 and 3 are going to be supplementary, and that 58 and 2 are going to be supplementary. So the opposite angles are going to be supplementary in isosceles trapezoids. Number 2, so we know this angle is 109. So since base angle, it's an isosceles trapezoid because the leg, we have hash marks here and here. So we have an isosceles trapezoid. So if we draw an isosceles triangle, okay, what we knew from an isosceles triangle were that the base angles were congruent, right? So if this was 50, this one was also going to be 50. That's exactly what we did in number 1. If this is 58, right, the base angle is going to be 58 as well. So since it's isosceles and this angle is 109, this angle is also going to be 109. So the measure of angle 1 is 109. And then we know angle 3 and angle 109 are, in the 109 degree angle here, are supplementary. So we know 180 minus 109 is going to give us 71. Okay, and then we know these angles are congruent. So if this is 71, this one is also going to be 71 for an isosceles trapezoid. Consecutive angles between the bases are supplementary. Base angles are congruent. Base angles are congruent. Consecutive angles between the bases are supplementary for isosceles trapezoids. Okay. And then we have 3. Okay. So again, 1 in this angle and this angle are going to be supplementary because they're consecutive angles between the bases. So here's a base. The bases are on the parallel sides. The bases are the parallel sides. The legs are the opposite sides. So again, we have congruent legs. Okay, so the consecutive angles between the bases are supplementary. So 180 minus 44 is going to give us 136. Okay, so this angle is 136. Okay, 136, which means angle 2. So base angles are congruent in isosceles triangles, which means this one is also going to be 136. And angle 3 here is going to be 44 degrees. Base angles are congruent. These are base angles, and these are base angles. These are consecutive angles that are supplementary because they're between bases. Okay, that's 1, 4. So we got 1 through 6. So we only got 6 more. That's halfway. These will go fast. All right. So 7, 8, and 9. Okay, we are going to have one more property to talk about. One more property to talk about. Okay, one more. Okay. Number 7 here. So we have an isosceles triangle. We know it's isosceles. Again, they should have arrows. I don't know why they don't have arrows, but they should have arrows to indicate. Well, they tell us. They tell us they're isosceles trapezoid. So I guess that's what it is. They're telling us it's isosceles trapezoid, so we know it's a trapezoid. It's isosceles because the legs are congruent. So we know this is a base, and this is a base. So we know these two angles are going to be congruent because base angles in an isosceles triangle are congruent. So 117 is going to equal 3n. Divide by 3, n is going to be 39-ish. Let's see. 40 is 120, so 39 is our answer. Right. 120 divided by 3 is 40. So 117 divided by 3 is going to be 39. Number 8, base angles are congruent. So 48 is going to equal 5n plus 3. These are our bases because these are the legs that are congruent. Subtract 3 from both sides. 45 equals 5n. Divide both sides by 5. N is going to equal, that is going to be 9. So n is going to be equal to 9. Number 9, this is where we get to the additional property. So in isosceles trapezoids, in isosceles trapezoids, diagonals are congruent. So again, that property is on your reference sheet. It's not the first time we see diagonals that are congruent. We know in rectangles the diagonals are congruent. So it's not just in rectangles that diagonals are congruent. It's also in isosceles trapezoids. So what are our diagonals here? Well, AC, again, diagonals go from one vertex to the opposite vertex. So our diagonals are AC and BD. AC and BD. In isosceles trapezoids, we know it's isosceles because the legs are congruent. We know the diagonals are congruent. So AC is going to equal BD. Right? AC is congruent to BD. So AC equals BD. So x plus 5 equals 2x minus 2. Subtract x from both sides. 5 equals x minus 2. Add 2 to both sides. 7 equals x. We want to plug it in, substitute it back in to see if it works. 7 plus 5 is 12. 7 times 2 is 14 minus 2 is 12. So we're going to get 12 and 12 when we substitute it back in. 7 plus 5 is 12. 2 times 7 minus 2 is 12. Okay, number 10, again, we have these hash marks that tell us the legs are congruent. So it's telling us it's a trapezoid. We know it's a trapezoid. We know diagonals are congruent, so 20 is going to equal 5x minus 10. Add 10 to both sides. 30 equals 5x. Divide by 5. X is going to be 6. Number 11. They're not telling us necessarily that they are isosceles, but it doesn't seem to matter because we know that those angles are supplementary. Consecutive angles in a trapezoid between the bases are, so this is a base, this is a base, so the consecutive angles between the bases are supplementary. So we know 6x minus 22 plus 8x plus 34 is going to equal 180. Combine like terms, we're going to get 14x plus 12 equals 180. Subtract 12 from both sides, we get 14x equals 168. Divide by 14. Okay, and that's going to give us, I believe, 12? 14? 12. 14 goes into 140 10 times, and then 14 goes into 28 twice, so 10 plus 2 is 12. So 168 divided by 14 is going to be 12. Okay, we can substitute back in to make sure it works. 6 times 12 is 72. 72 minus 22 is 50. 8 times 12 would be 96. 96 plus 34 is 100, and then 130. 130 plus 50 is 180, so we know we have the right answer. Number 12, I'm looking at, and someone asked me this question in class really quick at the end of the hour. I think it was 5th hour, and I think I gave him the wrong answer. I didn't know it was from this worksheet. I thought it was from one of the other ones, and I didn't even look close enough. So our tendency, right, this looks like that's probably what I did. I probably just looked at what it looked like. And the tendency is to say in a parallelogram, opposite angles are congruent. So we can set 5x plus 38 equal to 12x minus 28. This isn't a parallelogram, so we can't do that. They're telling us this is a trapezoid. Up here is an isosceles trapezoid. So we know that these angles, so we know that this angle is going to be congruent to this one. Okay, the base angles are congruent. So if this is 5x plus 38, this is also 5x plus 38. Okay, so it's going to turn out that this angle V and angle T are also going to be supplementary because you can substitute in V for S because V and S are the same because they're both base angles. Okay, so what's going to end up happening here is that these are consecutive angles that are between the bases, so they're going to be supplementary. So we're going to have 12, if I have room somewhere, 12x minus 28 plus 5x plus 38 equals 180. Combine like terms, we have 17x plus 10 equals 180, minus 10, subtract 10 from both sides. We get 17x equals 170. Divide by 17, and we get x equals 10. Substitute that in. 5 times 10 is 50. 50 plus 38 is 88. Hopefully the other one is 92. Let's see. 12 times 10 is 120. 120 minus 28 is going to be 92. So this one's going to be 92. This one's going to be 92 because U and T are congruent because they're both base angles. Okay, and then these two are going to be 88 and 88. So that does it for the trapezoid half of 6-6. I'm not going to do the kite half of 6-6 until Monday. I'm going to give us a chance to do it in class first. So this was just the trapezoid portion of worksheet 6-6 notes. So we did take some notes on it, and then we worked out a few examples, and you guys were supposed to fill in the other 8 or 9 problems.